Hi guys, today I'll be explaining the chemistry quiz of term 1 week 6. So let's start. Which statements are true about the gravitational potential energy? We refer to gravitational potential energy as GPE or EP. Now what about this gravitational potential energy or GPE? It always has a reference or zero level. That means it always has a level in which the GPE or the EP is equal to 0. Next thing about the GPE is that the GPE or the EP is equal to the negative of the work done by gravity. To explain it in a more technical term, we have this is our surface. If we are doing a force that goes upwards, is the gravity doing work, or are we resisting the work of gravity? We are resisting gravity. So if we are resisting gravity, then we are working with the GPE. This is a G. We are working with the GPE. Okay? If we are working with the GPE, then the GPE will be positive and the gravity will be negative. However, if we are going in the opposite direction, so if we are going downwards now, are we resisting the work of gravity? No. So we are working with gravity. However, are we resisting the gravitational potential energy? Yes, we are. So we are resisting the GPE. If we are resisting the GPE, then it's going to be negative. And if we are working with the gravity, then it's going to be positive. So remember, if the direction is upwards from the surface, the GPE is positive, the gravity is negative. If it is downwards towards the surface, the GPE is negative, the gravity is positive. Now, what is the rule of GPE? GPE is equal to plus or minus mgh. The plus is if it's going upwards, the minus is if it's going downwards. What does this mean? This means that the gravitational potential energy is proportional to the mass. So as the mass increases, then the GPE will increase. Okay. It's also proportional to the height. So as the height increases, then the GPE increases. Why did I not say the G? Because the G is always constant. It's always the same for everything. It doesn't change. So no matter what it is, the G is going to be the same. So now, based on what we explained, let's answer. The GPE of a body is proportional to its mass. Yes, we said it's proportional to the mass and the height. An increase in the GPE of the body is equal to the work done on it. We said no. If we increase the GPE, it's equal to negative the work done by it. So that means if we increase the GPE, the work will then decrease. So this one is wrong. GPE is always given with respect to a reference level or a zero level, which means the level at which the GPE is 0. Okay. Then the change of GPE equals negative the work done by gravity. We said yes, the GPE or the EP is equal to negative work done by gravity. So that means this is correct. The GPE of a body is proportional to the square of the speed. No, we said that the rule for GPE was plus or minus mgh. We don't have any speed in this equation, so definitely it's not proportional to the speed. Question number 2. Before we continue, let me write all the equations. We have GPE is equal to plus or minus mgh. GPE or gravity. Okay? Then we have work is equal to force times distance. Okay? Then we have the work energy theorem which states that the work is equal to the change in kinetic energy, which is kinetic energy final minus kinetic energy initial. We know that kinetic energy, I will write it as a side note over here, kinetic energy is equal to 1 over 2 mv squared. Okay, so if we're gonna follow the rule, then that means the kinetic energy final is 1 over 2 mass times velocity final squared, okay, minus the kinetic energy initial, which is 1 over 2 mv initial squared. So if you take out the common factor, we can deduce as a rule that the work energy theorem is 1 over 2 m times v final squared minus v initial squared. Please keep these in front of you. It will be very important. Now we will understand why. Now, a block of mass 2 kg, always write your given. We have mass is equal to 2 kg. Initially moving, so velocity initial is 10 meter per second. Okay? Then, is subject to a force of 3 newtons. So force is 3 newtons to the opposite direction. So it's going to be negative 3 newtons. The displacement. The work is displaced by 5 meters. So the distance or displacement is 5 meters. Now they need us to find the speed after the block is displaced. So it is velocity final. Now, let us rewrite our equations again. We have work equals force times distance. We have work equals delta kinetic energy, which is 1 over 2 m times v final squared minus v initial squared. Then we have W is equal to plus or minus mgh. Let us see. We have the mass, so we're gonna keep all the equations for now. We have the velocity initial. Which one has the velocity initial? This one has velocity initial, so we're gonna use it at some point. We have a force. Which one has the force? This one has the force. And we have a distance, so this one has the distance. If we're given the force and the distance, we can directly find the work. So the force, which is negative 3 newtons, times the distance, which is 5 meters, we're gonna get negative 15 joules as the work. Okay? Now we didn't finish. We found what? We found the work. As we need to find the final velocity. So look, which equation contains final velocity? This equation contains final velocity. So the work is equal in all the cases. So the work is negative 15 joules. It's gonna be equal to this equation, which is 1 over 2 m times v final squared minus v initial squared. What is v final? V final is what we need to find, so we're gonna keep it as it is. What is the mass? The mass is 2 kg. So now it became minus 15 joules is equal to 1 over 2 times 2 kg times the velocity final, which is unknown, minus the velocity initial, which is 10, so 10 squared. Then, if we're gonna solve it even more, I'm gonna bring it over here. We're gonna get negative 15 is equal to 1 over 2 times 2, which is 1, times v final squared minus 10 squared. The 1, you bring it over here, it becomes divided by 1. So minus 15 divided by 1 stays minus 15. So now we have minus 15, okay, is equal to v final squared minus 10 squared, which is 100. So we're going to move minus 100 to the other side. And we have what now? We have v final squared is equal to minus 15 minus 100, bring it to the other side, plus 100. So v final squared is equal to minus 15 plus 100. V final squared is equal to, if you do it on your calculators, minus 15 plus 100, it is going to be 85. So we have what? V final squared is equal to 85. But do we need the speed squared or the velocity squared, or do we need the speed only, not squared? We only need the speed. So to get rid of the squared, we're going to do a radical. So V final is equal to radical 85. And then if you do radical 85 on the calculator, you are going to get 9.219. They need it to the nearest integer, so if you round it, it will become 9 meter per second. Question number 3. A student of mass 40 kg. We start by writing our given. We have mass is 40 kg. Ascends through 50 stairs, each of height 30 centimeters. So we have the height of something, and we have g, which is 10 meter per second square. So he is going up. He's ascending. He is going up. Okay? If the zero level of the gravitational potential energy is chosen at the bottom of the stairs, okay? Then the potential energy we are looking for, the GPE. We said anytime something goes up, the GPE is positive. And what's the rule for the GPE? It is M times G times H. So it's going up and it's positive, and the rule for GPE is M times G times H. So we have M, we have G. What about the H? Where do we find the H? We're gonna simply do 50 stairs times the height, which is 30 centimeters. Remember, the height is always in meters, so it's gonna be 50 stairs times 30 centimeters over 100 centimeters, because we need to change 30 centimeters into meters. So it's gonna be 50 times 0.3, and on the calculator it is 15. Okay, so what do we have now? We have our mass, we have our height, and we have our G. So GPE, it's ascending, it's going up. The GPE, when it goes up, it is positive. So plus the mass, 40, times the height, which is 15, times the G, which is 10. So all in all, it's going to be 6,000 joules. Here, look in which unit they wanted. They wanted in kilojoules. So we're going to divide by 1,000, since they wanted in kilojoules, and we are going to get 6 kilojoules. So the answer here is 6 kilojoules. Question number 4. In a given interaction, the work done by gravity on an object of mass 4 kg is negative 30 joules. So the work by gravity is equal to negative 30 joules. They're asking, what is the change or the work in the gravitational potential energy? They're asking, what is the work by the GPE? If you remember in the first question, we said that the GPE or the EP, they're the same thing, just different representations, is equal to minus of the work done by gravity. So if here our work is negative 30 joules, okay, it's done by gravity, by the way, we're going to replace it. We're going to say the work done by GPE is equal to minus the work done by gravity. What's the work done by gravity? Minus 30. So the work done by GPE is equal to minus the minus 30 joules, which is then 30 joules. So very simply, just take the opposite number if you don't want to do this long process. Just see if the given interaction, work done by gravity, and they're asking for gravitational potential energy work, then take the opposite of the work they gave you. So here they give us minus 30 joules, take the opposite, which is then 30 joules. Question number 5. A box of mass 15 kg. First thing, you write our given mass is equal to 15 kg. Is lowered, it's going down through 2.5 meters. We have our height in meters. Use G is equal to 10. So we have our height is 2.5 meters and we have our G, which is 10. The work done by gravity. We said if it is gravity, okay, and it is descending or going down or lowered, then the work is positive. Okay. However, if they told us GPE, if they asked us the work done by the GPE, because it's being lowered, it will be negative. But here they are asking us for the gravity, so we're gonna take the gravity, okay. And we said since it's being lowered, then the work done by the gravity is positive. What's the rule for gravity? It is M G H. Very simply substitute. So it's gonna be plus M, which is 15, times G, which is 10, times H, which is 2.5. And on our calculator, 15 times 10 times 2.5, it is gonna be 375 joules. So the work done by gravity in this case is 375 joules. Question number 6. A column crane lifts 320 kilojoules. Okay, This is our first given. Mass is equal to 320 kilojoules. Sorry, kg, not kilojoules, kg. Of construction material up 12 floors in 120 seconds. So it's up 12 floors. This is our height. It's not the correct height, but it's height still given. In what? 120 seconds. So we have the time. Okay? They're telling us the height of each floor is 3.2. So we're gonna go here. We're gonna do 12 floors times the height in meters. So times 3.2. This is our height. And we have G, which is 10 meter per second. Now, they are telling us the power developed by the crane is, what is power? Power is equal to the work done in a specific amount of time. So what's the first thing we need to do before we find the power? We need to find the work. If you look here, we have the mass, we have the height, we have the G, the gravitation, and we have the time. So which equation can you use? Any of these to find the work. We know that work is equal to mgh. Okay? Now, plus or minus, in this case, it doesn't matter. We're just gonna take work is equal to mgh because they didn't tell us what. They didn't tell us gravity, they didn't tell us GPE. So if they didn't tell us neither gravity nor GPE, we use W equals mgh. Okay? So W is equal to mgh. By substituting, we're gonna have W is equal to 320 times 10 times 12 times 3.2. Okay, so 320 times 10 times 12 times 3.2. It is gonna be 122,880. This big number. So far, we did what? We found the work. Now, do we need to find the time? No, it's given to us. It's given 120 seconds. Remember, the time is always in seconds. So, the work is 122,880 joules, and the time is 120 seconds. So, to find the power, we're going to do the work over the time. So, 122,880 over 120, it is going to be what? 1024, not joules. The unit of work is watts. Don't do like me, I put joules, put watts, W. So here, the power developed by crane is 1024. The unit of power is watts. Question number 7. A ball of mass, we already have mass. Mass is equal to 1.2 kg, is moving vertically 2 meters above the ground. Okay, so we have the height, the height, which is 2 meters, and above the ground, so it's going up, okay, at 5 meters per second. So this is what? This is our velocity. Our velocity is 5 meters per second. They also gave us what? They gave us the G. G is equal to 10 meter per second squared. They're telling us the zero level of GPE is ground level. Okay, so they're telling us the ground over here, the level is 0 GPE. Alright, this is very important. The total mechanical energy of the ball. If you remember previously, mechanical energy is equal to what? Kinetic energy plus potential energy. Now, we're gonna go into it deeper, and we're gonna say that the mechanical energy is equal to the kinetic energy plus the gravitational potential energy. We're just adding a G to the potential energy, okay? The gravitational potential energy. So, first step, find all of the given. Or, first of all, let us expand the equation. We're going to have mechanical energy is equal to kinetic energy. What's the rule for kinetic energy? 1 over 2 mv squared, okay? Plus the rule of gravitational potential energy, we said it can be positive or negative depending on if it's going up or down, okay? And the rule for gravitational potential energy is mgh. Now, we have mass, we have height, we have that it's going upwards. If it's going upwards, upwards in the gravitational potential energy, then the sign is gonna be positive. So it's going up. We have our velocity, which is 5 meters per second, and we have our g, which is 10 meters per second squared. So very simply, we can directly substitute. We are gonna get mechanical energy is equal to 1 over 2 the mass, which is 1.2, the velocity, which is 5 meters per second squared. We're gonna square the velocity, so it's gonna be 5 squared. Now, since it's going up, it's gonna be positive mgh, so plus positive the mass, which is 1.2, our g, which is 10, and our height, which is 2. So again, I will repeat it. We have mechanical energy is equal to kinetic energy plus let me write it, kinetic energy plus the gravitational potential energy, which is 1 over 2 mv squared. This is squared plus or minus mgh. We have our mass, which is 1.2 kg. We have it's moving vertically upward, so it's positive. Since it's GPE, it's gonna be positive. Okay, and we have the height, which is 2 meters. We have our velocity, which is 5 meters per second. And we have our g, which is 10 meters per second squared. Now, we need to find the total mechanical energy. So to do it, we're just gonna substitute. It's gonna become 1 over 2 times the mass, which is 1.2 kg, times the velocity, which is 5 squared, plus, since it's going upwards, then the GPE is gonna be positive. The mass is 1.2 times the g, our g, which is 10, times our height, which is 2. So if we do it on a calculator, it's gonna be 1 over 2 times 1.2 times 5 squared, okay, plus 1.2 times 10 times 2. So all in all, we are gonna get 39 joules. So the total mechanical energy of the ball is 39 joules. Question number 8. A small ball is dropped out of a window of 14.4 meters above the ground. Neglect air resistance and take g is equal to 10 meters per second squared. The speed of the ball, they need V final, halfway through its fall. So whenever we have a case like this, where we need to find V final and we are not given the mass, this is what we're gonna do. We're gonna do mechanical energy initial is equal to mechanical energy final. Alright? So we know the rule for mechanical energy is kinetic energy. Here it's gonna be initial plus the gravitational potential energy initial. Okay, it's gonna be equal to the kinetic energy final plus the gravitational potential energy final. If we're gonna expand it, it's gonna be 1 over 2 mv initial square plus or minus mgh is equal to 1 over 2 v final squared plus or minus mgh. Now here it's h initial, here it's h final. First of all, look at this equation. You can cancel what? You can cancel the mass, and you can cancel the mass over here. You can also cancel the mass, the plus or minus mass, and you can cancel the plus or minus mass. So you're removing the things that are common on both sides. So that means our equation is gonna be v initial squared plus gh initial is equal to v final squared, okay, plus gh final. By reading, we have a small ball is dropped out of a window from above the ground. So before it was dropped, the height initial, okay, was 14.4 meters. And before it was dropped, it wasn't moving. Okay, again, before it was dropped, we had it in our hand. It wasn't moving, so there is no velocity. plus the gravity is always the same, 10. The height initial, it was out of a window 14.4 meters above the ground, so times 14.4. The velocity final, we need to find it, it's unknown, okay? Plus the g is gonna be the same, times the h final. If it falls, it will fall all the way to the ground, so the height final is gonna be 0. So this will go bye-bye, this will go. We're left with now what? We are left with 10 times 14.4 is equal to v final squared. So 144 is equal to v final squared, so v final is equal to 12 meters per second. 12 meters per second. Question number 9. A car of mass 1600 kg, very, very important, 1600 kg, this is our mass, accelerates from rest, that means our velocity initial was 0, under the net force of magnitude 800 newtons. We have the force is equal to 800. Then we have the speed of the car. We need to find the speed of the car, so v final, okay, after moving a distance of 100 meters. What can we do? We have force and we have distance, so we can do W is equal to force times distance, which is equal to 800 times 100, which is equal to then 80,000. Okay? Now we have the work, which is 80,000. We know the work is the same for everything. So 80,000 is our work, is equal to, we know another equation, which is that W is equal to 1/2 m times v final squared minus v initial squared. This is the law of, this is the work energy theorem. Okay, 1/2 m times v final squared minus v initial squared. If our work is 80,000, then it's going to be equal to 1/2 times the mass, which is 1600, okay, multiplied by the v final squared, which we need to find, minus the v initial squared, so minus 0 squared. If we're going to solve it, it's going to be 80,000 is equal to 800 times v final squared minus 0 squared. Then, if we bring 800 to the other side, we are going to get 100 is equal to v final squared. So, to get rid of the squared, we're going to do radical. We're going to get then that v final is equal to radical 100, which is 10. So we found v final, which is 10 meters per second. Question number 10. A 0.2 kg ball is dropped. So this is first of all important. Mass 0.2 kg is dropped. It's going downwards from the top of a 20-meter tall building. This is our height, 20 meters. And we have g, which is 10 meter per second squared. Okay? They're asking the work done by gravity. We said anytime it's going downwards, then the work done by gravity is positive. However, if it's going downwards, then the work done by the GPE is negative. Here they're asking for gravity, so it's going to be positive. So positive mgh. What is our m? It's 0.2. What is our g? It is 10. And what is our h? It is 20. So 0.2 times 10 times 20, it is going to be then 40 joules. Not negative 40, 40 joules. Question number 11. Okay, the quantities are related to the work done by the Earth. Sorry, which quantities are related to the work done by Earth on a falling body? Definitely, the work done by Earth on a falling body, what will affect it? The potential energy in the body Earth system, the potential energy in the body, and the potential energy in the Earth. Remember, you have what? You have work done by Earth on a falling body. So, what is the quantities related to the work? We have the potential energy of Earth plus body, okay, and the potential energy in the body and the potential energy in the earth. Okay? When you have two objects, for example, object A and object B, what are the works done? When it is falling, it is either the potential energy or gravity. Okay? So, potential energy or gravity. So, it's going to be the gravity or GPE of BA or A or B. Just choose them all if you have them all. Okay? Question number 12. What does a negative EP? Here is why I was using EP before, because it's equal to GPE. Alright, it's the same thing. We said GPE or EP is equal to negative work done by gravity. Alright, so if they're telling us we have a negative GPE, so we're going to multiply this by negative, and we're going to multiply this by negative. So negative GPE is going to be equal to minus times minus, which is plus gravity. So we're going to have a positive gravity, okay? Another thing, if we have a negative GPE, that means the object is falling downwards, all right? So up is positive GPE, negative gravity, okay? Down is positive gravity, negative GPE. All right, if we have a negative GPE, it's falling down. So here, the body is moving down because it has a negative EP. Very important. A toy car is projected across a rough floor. There is friction. As a result, the kinetic energy of the toy car is half. So, KE over 2 at a distance of 5 meters. So at 5 meters, it is kinetic energy over 2. They're saying the initial kinetic energy of the car is 4 joules. So at 5 meters, the initial kinetic energy is going to be 4 over 2, which is 2 joules. Okay? Now, they need the work done by friction on the car. If it was 4 joules, then it became 2 joules. What are we doing? We are subtracting 2 joules. So the work done by friction on the car is negative 2 joules. Alright? So the work done is negative 2 joules. Now the magnitude of friction of the car, we know that work is equal to force times distance. We found the work, which is negative 2 joules. It's equal to the force multiplied by the distance. Here the distance is 5. We need to find the force, so we're going to bring 5 to the opposite side. Now we're going to have force is equal to minus 2 over 5, which is minus 0.4. But here, watch out, they're asking for the magnitude. So we do not take the minus, we're only going to take the value, which is 0.4 newtons. Question number 14. A small ball of mass 0.2 kg, directly we have mass 0.2 kg, is projected at 10 meters per second. So we have our velocity is 10. Our velocity initial, in fact, is 10 meters per second. At a height, this is what our height is, 8. So again, the height is 8 meters. The only force acting on the ball is the force of gravity. So G is equal to 10 meters per second squared. Okay? Now the work done by gravity on the ball, if you see, the ball is falling downwards. So that means if it's falling downwards, it's gonna be positive gravity. So that means it's gonna be positive mgh. Again, our mass was 0.2 kg. Our velocity initial was 10 meters per second. And we had a height of 8 meters and G was 10 meters per second squared. Now, if we're gonna find the work, we need M, G, and H. So, which one is N? It's 0.2. So 0.2 times the G, which is 10, times the H, which is 8. So we're gonna do it on the calculator. 0.2 times 10 times 8, we are gonna get 16 joules. So the work done by gravity on the ball by the time the ball hits the ground is 16 joules. Now, according to the work energy theorem, the kinetic energy of the ball as it's about to hit the ground is, okay, we know that the work energy theorem states that delta KE, which is KE final minus KE initial, okay? What is KE initial, okay? Or let's write the equation first of all. It's gonna be 1 over 2 m times v final squared minus 1 over 2 times m times v initial squared. We have work is equal to 1 over 2 m times v final squared minus 1 over 2 m times v initial squared. This is the work energy theorem. Alright, now what do? We're gonna substitute. We have the work from part A is 16. It's equal to 1 over 2 times 0.2 times velocity final squared, okay, minus 1 over 2 times 0.2 times the velocity initial squared, which is 10 squared. So now, if we're gonna move this to the other side, we're gonna have that this over here, which is the kinetic energy final, okay, is gonna be equal to 16, okay, plus 1 over 2, 0.2 times 100, okay? So let me repeat that last step again. This is kinetic energy final. This is kinetic energy initial. We are missing here v final squared, so we cannot find the kinetic energy final because we need to find the kinetic energy final. Okay, so what we're gonna do, we're gonna move the kinetic energy initial to the other side. So now we're gonna have that the kinetic energy final, okay, so no need to put all these values because we only need to find the kinetic energy final. The kinetic energy final is equal to 16, the work, plus the kinetic energy initial, so plus 1 over 2 times 0.2 times 100. So we're gonna get that kinetic energy final is equal to 16 plus 10, which is 26. I'll repeat it again. Okay, we have the work energy theorem states that kinetic energy final minus kinetic energy initial. Okay, us we need to find the kinetic energy final. Alright, so to find the kinetic energy final, what are we gonna do? We're gonna move the kinetic energy initial to the other side, and now we're gonna have work plus kinetic energy initial is equal to kinetic energy final. Take the work from the first example we solved, it was 16, plus the kinetic energy initial. Kinetic energy is 1 over 2 times the mass, which is 0.2, times the velocity initial squared, which is 10 squared, is equal to the kinetic energy final. Then after adding, you get 26 is equal to kinetic energy final. Now the speed of the ball as it hits the ground to the nearest integer is, okay, we found now the kinetic energy final. Now we need to find what? We need to find the velocity final. What's the rule of kinetic energy final? 1 over 2 mv final squared. We have the mass, which was 0.2 times the v final squared. We know that the kinetic energy final is 26 joules. So 1 over 2 times 0.2 times velocity final squared is equal to 26. Alright? So that means if you move it to the other side, v final squared is equal to 260. Then if you do radical 260 in your calculator, you are gonna get approximately 16.1, and if you round it to the nearest integer, it is 16. Again, I'll repeat, we have the kinetic energy final, which is 26 joules. We know the rule for kinetic energy is 1 over 2 mv final squared, the rule for kinetic energy final. Okay, as we need to find what? The velocity final. To do that, okay, we're gonna do 26 is equal to 1 over 2 times the mass, which is 0.2, times velocity final squared. Then, after solving it, you're gonna get that velocity final is approximately 16. Question number 15. A construction worker of mass 90 kg, we have mass equals to 90 kg, is moving through floors of unfinished buildings. The height of each floor is 4 meters, so we have a height of 4 meters. That means this is 4, this is 4, this is 4, this is 4. Okay? The reference level for gravitational potential energy is chosen on the first floor. So this is the reference level, so 0 GPE. Okay? Take G is equal to 10 meter per second squared. What are they asking us? They're asking us for the gravitational potential energy. Remember, as we go down, gravitational potential energy is negative. As we go up, the gravitational potential energy is positive. Okay? So they're asking for the gravitational potential energy of the worker standing on the ground floor. We always start from the reference level. Where's the ground floor? It is down. So that means it's negative mgh. Okay? Because it's down, it's minus mgh. So minus 90 times 10 times 4. Minus 90 times 10 times 4. It's gonna be minus 3,600. But if they want it in kilojoules, we're gonna do minus 3,600 divided by 1,000. And we're gonna get minus 3.6 kilojoules. Now the gravitational potential energy of the worker standing on the first floor. We said the first floor is the reference level, so the GPE is 0. Directly, we put his GPE as 0. Now, the gravitational potential energy of the worker standing on the third floor. He's going up, so plus mgh. He's going up 1 level, 2 levels. This is 4, this is 4. So in total, it is 8. So now we have the mass, which is plus 90 kg, multiplied by g, which is 10, multiplied by the height, which is 4, plus 4, which is 8. Okay? So 90 times 10 times 8, it's gonna be 7,200. But of course, they need it in kilojoules, so we're gonna divide by 1,000 to get 7.2. So we're gonna have 7.2 kilojoules. Question number 16. Very important. A pump is used to lift. It's going upwards. 200 kg mass is 200 kg of water by the height of 6 meters. Height is 6 meters. In 2.5 minutes, we have the time. 2.5 minutes. We need to change it into seconds. So we multiply by 60. 2.5 times 60. It is then 150. Alright? We also have G, 150 seconds. We also have G, which is 10 meter per second squared. Now the work done by the pump against gravity. They're not saying by gravity, they're saying against gravity. What is against gravity? The GPE. So they need the work done against gravity, so the work done by GPE. If it's going up, then the GPE is positive, so plus mgh. So it's gonna be plus mass, which is 200, times the height, which is 6, times the g, which is 10. So all in all, it's gonna be 12,000. So if we're gonna divide it by 1,000 to make it kilojoules, it's gonna be 12 kilojoules. All right, that's for the first question. It's 12 kilojoules. Now the power delivered to the pump. Okay, we have 12,000 joules. Okay, this is our work. We need to put it over our time. We said 2.5 minutes was 2.5 minutes was 150 seconds. So we're gonna do work over time. So 12,000 joules over 150 seconds. On the calculator, it is then 80 watts. So the power delivered to the pump is 80 watts. Again, a car is moving at a constant speed along a horizontal rope. Its engine exerts a force of 5 kilonewtons, which is 5,000 newtons, moving the car through 880 meters. This is the distance. 880 meters in 80 seconds. First, they need the work done by the car engine. How do we find the work done by the car engine? We do force times distance. So 5,000 times 880. 5,000 times 880. It's gonna be 44. 4,400,000 it's gonna be, okay? Now, they need it in megajoules, so anytime we're dividing by mega, we're gonna divide by 10 to the power of 6. So it's gonna be 4.4. Actually, my bad, it's not, there's no more zero here. It's actually 4,400,000, so without this extra zero. So we're gonna do 4,400,000 divided by 10 to the power of 6. We're gonna get 4.4 megajoules. Okay, now the power developed by the car engine to two significant figures is, we said power was the work done, which was 4,400,000 joules, over the time, which is 80 seconds. So 4,400 over 80, we are gonna get 55,000. This is 5, okay? And to change it from watts to kilowatts, we're gonna divide by 1,000, and so we're gonna get 55 kilowatts. So now, question number 18. Very important. A block of mass 2 kg slides down from rest. V initial equals 0. The elevation of the inclined plane is 3.2 meters, so the height is 3.2. And we have G as what? G is equal to 10. Okay, so what do they need? Here they need the speed of the block at the bottom of the inclined plane. Very simply, first what do? We find the work. We know work is equal to mgh. They didn't tell us gravity, they didn't tell us the GPE, so we don't do positive or negative. It's gonna stay work equals mgh. So work is equal to 2 times 3.2 times 10. 2 times 3.2 times 10. It is gonna be 64. The work is equal to 64. Now, the speed of the block at the bottom of the inclined plane, according to the work energy theorem, W is equal to delta KE, which is the rule 1 over 2 mass V final squared minus V initial squared. Okay, so substitute it. 64, which is our work, is equal to 1 over 2, the mass, which is 2, times V final squared minus V initial squared. V initial is 0, so 0 squared. Then, if we solve it even more, 64 is going to be equal to 1 times V final squared. So 64 is equal to V final squared. To get rid of the squared, we're going to do radical. So then V final is equal to 8. Okay, so the speed of the block at the bottom of the inclined plane, which is V final, is 8. Now, very important, the slope, like how sloped the block is, like this, like this, like this. Okay, the slope will not affect the speed or the velocity. It will not affect, so it's going to be the same no matter what, as long as they have the same mass, the same height, and the same G. Okay, the speed is not going to be affected. However, the power is going to be affected. Why? Because here it's going to reach down in a quicker time than here. So here it's a bigger time. So let's say here the work was 64 over, let's say, 16 seconds. And here the work is also 64, but over 4 seconds. This one is going to be 4 watts. This one is going to be 16 watts. So definitely the one that is less steep, which is A in this case, is going to have a power smaller than the one with the steeper slope, which is B. Question number 19. Okay. A block of mass 20 kg, mass is equal, to 2 kg, not 20, is initially moving. Didn't we do this question? Question 2? Yeah, it's the same as question 2. So question 19, it's 9, but let me explain it. A block of mass 2 kg, mass is equal to 2 kg, is initially moving. We have V initial is 10 meters per second. Force of direction is opposite, so negative 3 newtons. And we have the displaced, so the distance is 5 meters. First, we find work. Work is equal to force times distance, so it's equal to minus 3 times 5, which is minus 15. We have our work, minus 15. Now the work is equal to 1 over 2 m times V final squared minus V initial squared. This is according to the work energy theorem. So minus 15 is equal to 1 over 2 times 2 times V final squared minus 100. So then we're going to have V final squared is equal to 85. So do radical here, do radical here. V final is approximately equal to 9. So here the answer is 9. Question number 20, it's the same as question number 3, I think. It's the same copy-paste, but I will do it again. So, a student of mass 40 kg ascends through 50 stairs. We have mass 40 kg. He's going up 50 stairs, each at the height of 30 centimeters. So the total height is going to be 50 times 0.3 meters, which is 15 meters. And we have G is 10. So the gravitational potential energy is going up, so it's going to be plus mgh. And then it's going to be 40 times 10 times 15, which gives us 6,000 joules, which is 6 kilojoules. So let's submit. I hope after 1 hour of explaining, there's not anything wrong, please. And thank God there's nothing wrong. I hope you guys enjoyed. I might do a separate video later about the equations, okay?